welcome back to the Distinction Factory where we make our mark. And today we are going to be going through some grade 10 Euclidean geometry, and these questions include midpoint theorem. So down here we have the June 2016 question 8 from the past paper. It says, in this question, you must give a reason to justify each of your statements. With Euclidean geometry, we know that that is the case with all questions. In the figure below, PQRS is a parallelogram. So it says that this shape is a parallelogram, so all of the properties of a palm also apply to this, meaning that your diagonals bisect with each other. It means that opposite sides are equal and parallel to each other, and your opposite angles are equal to each other as well. It says that diagonals PR and QS intersect at O. So here is PR and here is OS, and they are intersecting at O. They also do point out that this is 10 centimeters, this is 6 centimeters, and PO is 4 centimeters. They do also say that line TO is parallel to PQ. So that might help us. At this point, we can already spot some midpoint theorem, or rather converse midpoint theorem. And the reason I say that is because we know that the diagonals are bisecting. So those two lines, QO and OS, are equal in length to each other. And we also know that this line is parallel to this line. That means that we have converse midpoint theorem, which will help us to prove that PT is equal in length to TS. Okay, the first one wants us to calculate the length of PR. So they want us to calculate this entire length over here. And a way for us to do that would be to use the diagonals bisecting in a palm method, because we already know that this is 4 centimeters, so this will also have to be 4 centimeters, meaning that the full length of this line will then be 8 centimeters. So now we just have to put that up in words. Question 8.1, we're going to tell them that PO is equal in length to OR, and our reason for that is because diagonals bisect in a parallelogram. That means that OR will also equal to 4 centimeters, and therefore the full length of PR will then be 8 centimeters. Question 8.2, it says calculate the length of ST. So for this question, we are going to use the converse midpoint theorem that I pointed out earlier. And we also know that opposite sides of a parallelogram are equal. So if this is 10, this side will also then be 10 centimeters. And we're going to prove that they are bisected, they are equal in length. So this will then have to be 5 centimeters. So now we just have to write that up in words. We're first going to give them the full length of PS. So PS will be equal to QR, and that is because opposite sides are equal in a parallelogram. That means that PS is 10 centimeters. Okay, from there we have to prove our converse midpoint theorem. So we're then going to tell them that, that QO is equal in length to OS, and our reason for that is diagonals bisected. And we're also going to point out that line TO is parallel to line PQ. TO is parallel to PQ. And my reason for that is given because they did point it out to us. So because of those two things, we can then say, therefore, PT will then be equal to TS. And my reason is converse midpoint theorem, but we're going to have to write that entire paragraph for our reasoning for this. So let me just write that out. Okay, so our line drawn from the midpoint of one side and parallel to the second side will then bisect the third side. That then means that ST will equal to 5 centimeters. All right, cool. Then we can work through question 8.3, which says calculate the length of OT. So for this, we're also going to use normal midpoint theorem, which will then be that PT is equal to TS, as we have just proven to them. And we also know that this QO is equal in length to OS. And because we have two midpoints, T being our first and O being our second, that means that this line and this line have something in common with their lengths. It means that TO will be half of the length of PQ. All right, so now we just have to write that out in words. I will do that on our next page. All right, so question 8.3. We are first going to point out that PT is equal in length to TS, and that was proved above. We are also then going to point out that QO is equal in length to OS, and that is because diagonals bisect. And then because of those two things, we can say that TO will be equal to half the length of PQ. And our reason for this is midpoint theorem. That means that TO will then be equal to 3 centimeters. All right, so for question 8.4, they want us to prove by calculation that QPR, which is talking about QPR, so they're referring to this angle over here. They want us to prove that that is 90 degrees. So the way that I'm seeing us do this is by using the theorem of Pythagoras. We know that this is 4 centimeters, so this line will also have to be 4 centimeters, meaning that it's 8 centimeters in total. So we can use Pythagoras and prove that this is the hypotenuse of our triangle, PQR. Therefore, this will then have to be a 90-degree triangle there. So we are going to tell them that PO is equal to OR. And again, that is because diagonals bisect. And that means that PR will have to be equal to 8 centimeters. So because that's 8 centimeters, we can now use theorem of Pythagoras. So we are going to say that PR square plus QP square should equal to QR square. So we can substitute PR is 8 centimeters, QP is 6 centimeters, and that should give us QR. I want to square root this entire thing here so that we get our final answer to be 10. And then we can say, therefore, QPR is equal to 90 degrees because of theorem of Pythagoras. All right, I hope that has helped you guys. Let me know if there are requests for any other past paper questions that you would like me to go through with you, and hope to see you in the next video. Thank you.